Hey guys, welcome back to the channel. I have a interesting video here, kind of like more information than anything because I have not been able to actually reproduce the concern of the customer. I've been trying different options, including testing my own computer. This is a 1999 2007.3 diesel PCM. The customer concern says that as soon as he tries to establish communication with the computer, the car dies, which is, I know that he's trying to see if the problem is in the computer or not. Right now, I'm connected to the computer. I want to show you that. So this is the same computer. It has a different digits than mine, but you will see the first right here, XC3F128650. The last digits are different. Let me get mine. Carefully in there. You can see that it's XC3F. And then just the last digits, this is a BF, that one is a EBD. The internals on the board, so you guys can see right there, they're exactly the same computer. So, and this the same thing on the other side. Let me just keep you there. So again, his problem is communication. This is coming from A&A Brothers Auto Repair. They're in Lorton, Virginia, and they took, I got this computer here. All right, so what I have now is, again, I already did this wiring for the 7.3s. I got also the SPC positive and SPC negative, which is in pins 15 and 16. That's how these communicate. They go to pin 10 and 2 in the DLC. And that's exactly what we're looking at in there. I have put the numbers in there. Disregard the yellow channel because I was using for my own testing as it's been, a long day trying to duplicate this, seeing if I see problems. Because when I was looking at the way this communication is established in the computer, it goes through these two transistors. This is actually two devices in one. This is a Scotch. Let me just see. Scotchy. Let me open the folder so I can get you the correct information. Where did I put them? Engine diagrams. Might be on this other folder. Right here. So it has two transistors. One is a PNP transistor, a Scotty diode module. So if I go over to my data, and I open this folder, this picture, again, don't look in the internet for this because you're not going to find it. So this is the way they are in here. So again, pretty easy to see. This is a picture from another computer. Again, same print as far as the devices inside. But as you can see, this one is a 1C3F, not a XC3F. So this might be a little different, all for a different vehicle, but it doesn't matter for me as far as the signals and everything is the same. But yeah, so 16 goes to DLC2 and it's a 0 volts to 5 volts. So it's a pull up, signal. 15 is a DLC10, 5 volts to 0. It's a pull down. So it's pulling down the 5 volt reference to 0, and that's how the signal is created. And this is the circuitry involved into that, and obviously goes down to the microprocessor from here. So these are again, this one is a NPN and this is a PNP, and we can see that in the data here. It's a dual component because we can see that it has again the Schottky. That's a little hard word for me to say it. Is a for the 4 pins. So we have one is the anode, and the will be the 1101, which is the NPN. And then 2 is the base, 3 is the emitter, here 4 is the collector. I gather all the data, I know how they work. So the 11 is the one that has the 5 volt reference pulling it down to ground, and that's why the Number 3, the emitter, is connected to ground. And then 15, which is the pin number 1, the anode, is coming through a current sense resistor as a protection, because we got the 5-volt reference in here, and this is directly the signal all the way to the pin 15 on the computer. So this is how this works. So this will be pulling it down as is commanded on the base, which is pin 2. We can see that in here. So if we go over to pin 2, that's the base. So as communications is established, it will, and it does it through another small diode in here. But so for my testing, this is all I wanted to see if I, can find any issues. Right now, the computer is being plugged in probably, I don't know, maybe 30 minutes. I have not lost communication. And what I was doing is just, establishing, if we go here, I'm going to show you again, we can see that is the communication on that current sense resistor. Remember, we were just seeing on the picture. I'm probably going to put them on the image so you guys can see. And if I touch the other side, we can see that it's just a steady 5 volts. So this is as a protection, so we're not pulling the entire 5-volt reference down. It's just through a resistor, and then, that's how it works, because it's just a signal. It doesn't really need amperage, it's just a signal. We can see here, as just a ground. In this regard, the 0.2, because that's just the line that I put, but you can see it's 0. And then the actual base, you see, is a very small signal. It's like a 0 to 1 volt. Let me snap that capture, and we can revisit that signal. It's very fast, so hopefully I get it to catch it. It's right here. So if we can zoom in here, or yeah, let me just zoom in a little bit. This will be matching perfectly the signal that we have up in the top, and I'm going to show you that in a second. Let me just put the cursors in here. I'm using Pico 7, and I divided the view into 3. Yeah, so it's a 0 volts to 1 volt. I can also go into views. I can close all this. Just leave one scope view, and then I can go into views and then put all the channels in here. So we can move the signal down. Come on. Hopefully it's not frozen. No, it's not. It was a little frozen, the image. Because been working a little weird today. The software is not too happy. I'm using the early version because I was having problems with this. As you can see, I'm trying to move it and it's not doing it. Okay, let's see if I can move the blue channel. Come on, don't do this. Yeah, it's not responding. Well, let's try now. It's not letting me do it. All right, give me a second, try to fix this up, and I'll be right back. I have to open and close the scope again. So now it looks like it's reading properly. So let me just capture one. I changed the settings a little bit, but let's stop that. Just hitting the space bar on your keyboard, you can stop the signal. Let's go back to where we have the 3 signals right there. So again, I was a little hesitant, worry when I saw all this noise in this signal. They all have the same filter, so I can change the filter a little bit and try to clean that a little. But remember, I don't want to clean everything because not everything is noise. But yeah, as we see, red and blue are a perfect image of each other. So that right there, if I get to zoom into one event, remember, we will call this 2 events on the screen, and I'm calling or zooming into one. So we can see that. I can make also, if I go into here and I'm going to display, so display, I can make that image a little smaller this time. I don't really need to go that big because like that I can see all in the screen, right? So let's bring it down to half. Like that we are able to analyze the data better. Let me see if I did the same with the blue. 0.6, now it's 0.5. So, but as you can see that the signal is indeed happening, and we know that this is somehow being read because it's producing the signal. So what is the computer reading or not? I'm not sure because, of course, that will be more into engineering than anything, and that's not what we're doing here. But if we go into the next part of the image, oh, and that's the connector abnormal. Please reconnect in 3 seconds. This is kind of like what he's saying that he's happening, unable to communicate. And I don't think this is actually the computer. I think this is actually my scanner. It run out of time, no touching or anything. So let's exit. I didn't need to exit, but okay. So let's select 4 again, because this you will see that also another thing that I forgot to mention is his bin number is not matching what the computer, because he gave me a bin number which is actually in the case. Let me just get it 1 second. I got a lot of work to do and I'm leaving the country in less than a week. Not sure how much I'm going to be able to do. But yeah, so this is the bin that I have in there. So F, and just look at the starting FD or FDWW and then the last 540254027. All right, so if I do manual search, let's see if, sorry, automatic search, let's see if we can reconnect. If it reconnects, that means it's the scanner timeout and not the actual computer. Because I don't see nothing wrong with the communication, right? Yeah, you can see this is reading. But you see the VIN number, this is 1FDA. The one he has on the sticker is 1FDW. The last digits are not even correct. So because I have in the sticker EE54027 and we got XDE or ED00540. So, and this is for a 550, not for 350. So the information is correct, and then you see how it's being decoded as F550 1999. So not sure why he has that like that, because not sure if this is locked onto these old vehicles, but this might be his case. This might be not the correct computer for his vehicle. I can reprogram that and use it, but you see, I don't think there's any issues with communication. The issues we are actually seeing in here is just the scanner timeout, no activity. Because I'm not recording. If I put probably a record or something, let me actually try that. I'm just going to select the battery voltage. Nothing really matters. Case ground, let's say. And let's say record. Let's see if we are recording. Problem is, not even know where to erase those later. Because I don't think like this, the scanner will go into timeout. But yeah, so going back into this signal, and that's what I was going to show you. If I do a zoom on the second part of the message, we can see that, this is the same image, again, 0 to 1 volt. But then even though when this one is not here, we are getting these signals or these hashes in here, but is considered a message. So not sure if we have to see the entire, because right now we're just looking at um, channel difference, right? So we're not, or each channel, not what most likely a computer will be comparing the signal as a complete, like A minus B, like when you're doing CAN. So, but again, this is what I see. I'm going to connect my computer. Let me stop this because I know this is not going to. So let's cancel that. Saving is canceled by user. So yeah, I don't want to record that. So yeah, no problems on communication. Because if it would be a problem in communication, I will not be seeing this. So again, there's both signals, which is at the end what the scanner is looking for and the computer is looking for. They're all look good. They're a perfect image of each other. No problems. The amplitude is correct. Again, blue channel, which is in DLC 10, it will be a 5 volts to 0, and then the red channel connected into DLC 2 will be a 0 to 5. and it's sometimes high and low, depends on the message. Let me stop right there because you see the beginning of the message, we have a lower than 5 volts, and then the last part of the message is high. But then on the second part of the message, this is high, and then this is low. And that's probably how I would like to address that. You know what? I think this is it. Let me run this scope again. Let me see the signal. That's it. All right, so let me stop that. This is exactly why sometimes it's important to analyze the data, and I want to share this with you. Because if we see, when we're talking about the hatches, now this is it. All right, so this is, you see, when it's lower than 5 volts on the red is when we are getting these hatches, and then when it's high, we get the communication. And red, when it's full 5 volts, we get the signal. When it's lower, is what I'm calling a hash. So the actual message is here and here, not in here and not in here. And I think I'm correct because we're establishing communication and everything is good. And I think that's how is the how this is work, or how this will be translate. All right, so let me switch to computers. Again, you will see the numbers in here, some numbers that somebody else put in here, and then we have a EVD at the end. Sorry, I was talking and maybe not guiding the camera right, but let me switch to computers and I'll be right back. All right, quickly transfer the computers. You can see this one has my name, and there's again PF at the end. Let me turn the power on. I'm going to run the scanner so you can see when, sorry, not the scanner, the oscilloscope. When the scanner is not connected, there is nothing going on the SPC bus. So if I do the automatic search, as soon as it tries to communicate, we will see something on the right there. You see the signals. They're trying to establish communication. They look good. This is at 2000. Is the correct information? Yes. Let's stay with the same B number. Just because I didn't get completely out, I should probably try to do that like that. You guys can see. Let me completely get out. For Because as we establish the communication with the computer at first, I want you to see that this one will not read the beam because it's not saved on it. But if I do an automatic search, all it's going to say it is a 4. But since there is no beam on this computer, it will be not selected as a F-550. It knows that it's a 7.3 diesel. Yes, it does know that, but it does not know what 4 is for because it's not being completely to read. So it's just an F-Series Super Duty, but no beam number. So definitely that beam that we read before is definitely from there. And let's enter the PCM, because all I want you to see is the communication data. And we're going to select just the same pits, the battery, and the case ground, just to have something in here. All right, so we have the same looking waveforms in there. I'm going to touch the same exact location right here. And I want you to see that we have exactly the same thing. So let me just stop that capture and go back to that waveform. Right there. So we are looking at the same thing. When we have this hatch is when it's down on the red one, and as soon as it goes up to 5 volts, it's complete. Same thing in here. This is all 5 volts. As soon as it goes lower than 5 volts, there is no signal. So that's how it's read in here, because if I put, let me put a cursor so you guys can see that this is indeed around 5 volts. I have to zoom more, but you can see 4.68, and it's definitely being pulled from ground. If I do the same thing on the green channel, sorry, not the green, the blue, we are around 5 volts to 400. So that is the way this is. This is being read. The difference in between the high portion of that signal and the low portion of the signal is around 1 volt, and that's why the signal is not being read in here. Because remember, this signal is only 1 volt of amplitude. So let me zoom in here, since we're doing a measure. Actually, which one is easier? Either way, right? So yep, we're pretty close to the reality of the signal. But yeah, we have on the red channel 693 millivolts. Sorry about that. I was a call I have to cancel. But yeah, as you can see, so we got around 690, 700 millivolts. So this will be almost the amplitude size that we have here, right? Because if we measure that yellow channel again, so we got 1.1 volts, and it starts around close to 100 millivolts. So it's around 1 volt of amplitude. So if this signal goes down 700, that's where we got these little hatches. It's not enough to be considered a message, right? So it has to be higher than this. So this is kind of like the threshold of the signal, but it's communicating good. And this will happen, the same thing that you saw there about, losing communication. It will happen with my computer. I have tested it. I mean, I've been working on this the entire day. And this is sometimes, what is a little frustrating, because, when I have a computer like this that all I can perform is a test, uh, my pay is minimum. I mean, how much do I charge to test a computer divided by 10 hours or 8 hours in a day? I get paid what, like $20 an hour? Sometimes it's just a waste of time. But it's part of the trade. I'm trying to help others. It's not always about money, but especially if I'm going on vacation, I'm looking for a little extra cash to take on the vacation, right? But yeah, so right, guys, this is just like I said, more information video than repair, because I cannot really duplicate any concerns. I don't see this computer shut down. I don't see this computer losing the communication. It's exactly an image mine to his, and this is a known good computer. The only thing that I don't have in this one is his BIN number. Not sure if that will create a problem on his um, car, but that is something that he's going to have to figure out. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. And as we said in Costa Rica, pura vida. Talk to you later. Bye bye.